StarGAN is trying to map or do the translation from one domain to another domain, but then you're increasing the number of domains that you have. It peaks to peaks was from one domain to another domain. Here you have multiple domains. For instance, the domain of blonde hair people, the domain of people with different genders, people having different ages, having pale skin, etc. One solution is to have a generator that's going to take you from domain 1 to domain 2, another one that's going to take you from domain 2 to domain 1. And now if you want to translate from domain 1 to domain 3, you need to have their own respective generators. And then soon you're going to end up with a lot of generators going back and forth. And then you need to train all of them. This might be a good strategy if you have a lot of data, because in that case, you have enough data to train all of these, and each one of them are going to specialize for a pair of domains. And then you can say that, you can argue that memory is cheap, storage is cheap, so I can afford to store the checkpoints of a lot of models on my hard drive. And whenever I need to translate from domain 1 to another domain, I can just call and load the corresponding generators and do my translation. And that's a valid argument in the case that you have a lot of data. That's going to give you more flexibility. But if you have less data per each domain and you want to do transfer learning across domains, then it's a good idea to share parameters and have a single, perhaps giant generator. And then if you want to translate from domain 1 to any of these other domains, you're just always going to go through the corresponding generator, only one generator, whose parameters are shared between a lot of domains, and it has seen data from all of those domains. And this, we saw a similar idea when we were doing translation for text, when we had a giant model translating from English to all sorts of languages. Maybe, I guess we scaled it up until 100 languages, if you remember that cross-language model. And this was useful for low-resource languages. It's the same thing here. It's useful if for one of these domains you don't have a lot of data. And the idea is you're going to have a discriminator discriminating between real and fake, and at the same time classifying the domain. For instance, here you have 1, 2, 3, 4 domains. It's going to classify between 4 domains. And when you are generating and when you are training your generator, you specify the domain. For instance, you say, I want to have an image for this particular gender. That's going to be the target domain. You input your image, and then that's going to give you your generated image. But then it's a matter of training it. You take that fake image, show it to your discriminator, and your discriminator needs to say it's real or fake, and at the same time classify it. And then we saw this idea of cycle consistency. If you take the fake image, give it the original domain, the reconstructed image should match the original image. The rest of it is just its math. And then you can have multiple domains as well, or multiple data sets. Same strategy. One hot vectors is going to do the job for your domains as input. We are going to borrow ideas from improving the training of GANs, especially the gradient penalty idea. We covered it. And then it's going to give you nice looking images. Now you can transfer this image to be angry. Okay, perfect. Any questions? Awesome.